Good morning. This video is going to go over the different parts that make up chemical reactions. So when we write it up, what do the different sides mean? What do the arrows mean? What do the numbers mean? That kind of thing. So a chemical reaction by definition is any process that changes one set of chemicals into another set of chemicals. Typically it's written in a way where, you have a set of chemicals on one side and then an arrow and then a set of chemicals on another side. The chemicals or the compounds that are on the left side are called the reactants, and they're basically your ingredients. What are you putting into the reaction? The chemicals on the right side are going to be your product, or what you're actually making. So in this example, we have two molecules of hydrogen peroxide. They're going to undergo a chemical reaction that's indicated by the arrow to make two molecules of water and then a molecule of oxygen gas. Now, what else can a chemical equation actually tell us? Well, a chemical equation is written to tell us a lot of information. First of all, we've already talked about that you have the reactants or the ingredients on the left side of the arrow. Okay, so in this case, the hydrogen, the oxygens, those are all going to be reactants. The products are on the right side, so in this case, it's water. Now, we can also look at the numbers that are involved in a chemical equation. So a number that's in front of an element or a compound is called a coefficient. And what that represents is how many of these compounds are needed in the reaction. So in this case, there's two molecules of hydrogen gas that's needed to get this reaction going. There's one. When there's no coefficient, we just assume that it's one. There's one molecule of oxygen gas. Okay, so kind of think about this like in terms of using a recipe, right? You don't just say teaspoons or tablespoons, you say 3 teaspoons or 3 tablespoons, depending on what you need. And that's the same thing with the coefficient on a chemical equation. There are also these subscripts here, and we've already talked about what those subscripts mean. Those are when we, way back in week 1 or 2, used the periodic table to make sure that the compounds were balanced electrically. There's also this arrow, again, that represents that the reaction has occurred. And then these letters, so either S, L, or G, indicates the state of matter. So in this case, G is a gas, so it's hydrogen gas, oxygen gas, and then water, H2O, is going to be in the form of a liquid. So by looking at all the information that's provided, we can tell a lot about what's happening in the chemical equation. I always think of a chemical reaction or equation like a recipe, right? You are starting with certain things. So let's say we want to bake a cake, right? Our product is going to be the cake, but we have to mix all of these different things together in order to get it. So we got oil, eggs, milk, sugar, water. Those are our reactants. Those are our ingredients. And we know that when we put it undergoes a chemical reaction, we put all of those things, mix them together in specific amounts, right? 1 teaspoon of oil, 3 eggs, 1 cup of milk. That when we heat it in an oven, it changes into a product that is completely different than each of the individual reactants, right? At the cake, you can't separate out the eggs from the cake. You can't separate the sugar from the cake. So we know that a reaction has occurred. So one way to tell if a chemical reaction has occurred is to see if the original reactants can be recovered. And if they can't, then you know a chemical reaction took place. So what you're starting with is the reactants. What you end with is the product. And in the next video, we're going to talk about how there are different types of reactions. In this reaction, we're building something. In some reactions, we're breaking apart something.